Okay, so today we're moving on to another kind of factoring, and this happens when we have an A of 1. So the general format of things that we will factor is ax squared plus bx equals c. That's generally a polynomial that has 3 terms and an exponent of 2. This is what we call a quadratic equation, and these are very special equations that we're going to focus on in this chapter. So for today we are focusing on polynomials that have an A of 1. Okay, so the first thing I'd like to do is go back to the concept of FOIL. And when you're foiling very simple FOILs, you will end up with these trinomials, these quadratic equations. So on your own, complete the following table, and we'll talk about a pattern that you might see when you finish. Okay, so now that we've finished the table, let's go ahead and take a look. Is there something you notice about the last term of each? Well, hopefully you realize that it is the product of the 2 second terms. What do you notice about the middle term of each? Negative 2 comes from adding both. So hopefully this seems familiar to you. If I add those, I get 1. If I multiply those, I get 6. If I add those, I get negative 9. I multiply them, I get positive 20. I add those, I get 7. I multiply those, I get 6. So what I want you to realize here is that in order to go from the quadratic to the factored form, I need to keep in mind factors and sums. And this is what we talked about last week. Factors of 20 that add up to negative 9 are negative 4 and negative 5. We talked about this. When you add them up, they give you negative 9. So, when we were talking about the idea of factors of negative 8 that add up to 3, I was talking about factoring a trinomial, x squared plus 3x plus negative 18. You're always going to find factors of the last number that add up to the middle number. So to factor this, I'm thinking about negative 1 times 18, negative 2 times 9, negative 3 times 6. That's the one that works. And so to factor it, it is as easy as x minus 3 times x plus 6. Now remember, this only works when you have an x squared, an A of 1. Let's try some of these. So I'm looking for factors of 30 that add up to 13. 1 times 30, 2 times 15, 3 times 5. How about 3 times 10? That one works. So x plus 3, x plus 10 is your final answer. Try the second one on your own. Factors of 24 that add up to negative 11. So that's a negative times a negative. There's the one that works. So x minus 3, x minus 8. Try some more. Factors of negative 35 that add up to negative 2. 1 times 35, 2, 3, 4, 5 times 7. And if the 7 is negative, that'll add up to negative 2. X plus 5, x minus 7. Try another one. Factors of 10 that add up to negative 6. 2 times 5, 1 times 10. Negative and negative. Gee, I can't think of any other factors and this isn't working. So guess what? When we can't find any factors besides the one that is given, it is what we call prime. Now, here's a little reminder. You should always check your result. You can check by multiplying the factored polynomial to make sure it equals the original. Many times you can find computational errors or errors in the signs by checking your result. So, in this example here, if I FOIL it, I should get the original problem. And when I combine like terms, I do. Let's try a little bit more difficult ones. Ones that are not necessarily x squared, but are still possible. Okay, so let's see here. We need factors of 6 that add up to 5. That's going to be 2 times 3. Now what's tricky here is this is an x squared, so that comes from x and x just like last time. This is a y squared, so I need a y and a y. Add in my 2 and my 3. Now in this case, you really want to check it to make sure it works. Why don't you try the second one? Factors of 6 that add up to 5. Same thing, 2 times 3. But instead I've got an x to the 4th, so this is x squared plus 2, x squared plus 3. Check it to make sure it works. Now, sometimes you can't factor it right away. Sometimes you need to do the first step, which is the GCF. You always want to check for a GCF before factoring. In this case, I can divide everything by 3. That gives me 3 times the quantity m squared minus 8m minus 20. Now to factor this, I'm looking for factors of negative 20 that add up to negative 8. So, it's got to be negative times a positive. What about 2 times 10 with the 10 being negative? So I still have that 3 on the outside, but on the inside I've got m plus 2 and m minus 10. Why don't you try the second one on your own? Divide by a common factor. Common factor goes on the outside. Now I'm looking for factors of 42 that add up to negative 13. How about negative 6 times negative 7? So the 2x stays on the outside. X minus 6, x minus 7. Final answer. So hopefully you're getting the hang of this. I'd like you to do some more practice on MyMathLab Chapter 6-2, and remember to show your work. When you finish, you can play some more math multiplication games. Remember, the link is on Google Classroom.